Hello all. Thank you for coming and being interested in this subject. It's very important that we understand these things so that we can make the world the functioning place it needs to be. I'm inserting this one late in the set because so if you came and or if you've already watched some later videos, you've been directed to come back here and watch this one if you haven't. And so if you're watching them now in series, this is nice. You get to see this one before the later ones. This one was inserted now because I wasn't clear how to present it. I knew the math that I was using in my invention, as well as in my as well as with the forthcoming that you're going to be seeing, was different than normal math that's used. I've since learned that there's other people questioning the math, as well as other people stating, time vectors of agents of something, time agents. And so what I'm trying to say is what I'm presenting here is starting to be confirmed already in the world. And so I'm very pleased. And so this math now is going to be able to, what I'm going to be able to do with this math is make a connection between Newtonian mechanics and quantum mechanics in deriving these equations. And of course, these equations, the four fundamental forces of nature, the way they're presented here and they're useful in this form is in the world we live in, in the Newtonian mechanical world that we live in. Because this is basically saying the mechanics we've been living on for the last umpteen years works. It takes us down to the four fundamental forces, and from those four fundamental forces, we're now be able to look deeper into them so that we can see more mechanical advantages that we can receive from these four fundamental forces of nature. And my invention is proof positive of those mechanical advantages we're yet to experience, or we're at the threshold of experiencing as this invention is completed its testing phase. Anyway, let's get right into the math. We're already 2 minutes in. I was a little concerned about how to present this in a rational way, because there's a lot of ways to present it. In fact, I've already presented this information in bits and pieces on other videos in the series. Nothing's going to be inconsistent with what's here. This is just basically saying this is the background behind it. I've been using the car in my videos. This is how you build the car. This is the math behind it. I asked DeepSeek a question about quantum mechanics math, and this is the summary he gave me, or it gave me. Summary: in quantum physics, the movement of electrons in atoms is described by wave functions and quantized energy levels. So basically we're saying that math jumps in discrete positions, okay? It's not, let me just keep reading. Electrons can only occupy specific energy states and transition between them in fixed increments, emitting or absorbing photons in the process. The mathematical framework involves solving the Schlosser-Dinger's equation, forgive me for stating it badly, which yields direct energy levels and probabilistic descriptions of electron positions. This contrasts sharply with classical physics, where energy and motion are continuous. So you see there's a clash with Newtonian physics, classical physics. The physics that people now today use in Newtonian mechanics is limited and not including this portion of it, is what I'm trying to say. In other words, we haven't been using the math correctly in all places when it comes to using Newtonian mechanics. And I'm proving that by being able to derive these equations from Newtonian mechanics, the exact same equations that is the Heisenberg uncertainty principle math. Here it is: position, momentum. That's the equation. delta R is the uncertainty position. Delta P is the uncertainty of momentum. And this is really the observer, whether it's going to be, this has to do with the triple slit experiment. I mean, that's what this is about. What is it going to collapse into? And of course, that's what this is right here. Space, velocity, whether it's going to collapse into mass or not. Or is it just going to be an energy in space? Is it just going to be a gravity? This gravity could be put here as well. I just put the L, but the gravity could be put here. Because the L doesn't occur without the gravity. Like, it would have been more correct if I'd have put it in that form here, the G. Because then that way all four of these would have been present here, but they're not. The way it is, I've got it drawn here, is just the L. I mean, the G is absent, and it should be here as well. And it would be presented with this, just to correct it before we go any further. But the point I'm trying to say is the math that I use is basically, I've been calling it whole set math, infinite math, but in reality it's this math, which is the math that's used in quantum mechanics. It's whole set math from the viewpoint increments that I just read, discrete increments. And that's how these equations are derived. What we would do is we would find a time that would be equal to 1 or equal to the speed of light, and then we would set things equal to unity 1 in that position, and then we would see what would drop out. Because what this is about is reducing it to its smallest, to its most fundamental form, so we can find out what the most fundamental forces are. And so that's what we did using this math in Newtonian mechanics equations, which is mgh 1/2 mass times velocity squared. And of course, also I hijacked the Einstein equation, mass equals c squared, and I adapted it to fit in with Newtonian mechanics. And I actually used it, once I did that, to derive these equations as well. And from my analysis of the different systems, I was able to prove that these two equations, that these two are actually two independent equations mathematically. In other words, they can work against each other. They don't collapse into nothing. They collapse into one. They collapse into unity, so that they're independent. In other words, you can set them equal to each other and get work done. And that's what my invention does. And if you're clever enough, you can learn to extract extra power from that. Hopefully my invention will prove that in the next few weeks, upcoming days. Anyway, I'm not quite sure that I haven't covered all of this already, and we're right at 8 minutes, and I know I've done some rambling, but hopefully I've made the point is that the position is equal to the distance in space, with regard to the Heisenberg uncertainty principle, and the observer, of the principle who decides what it's going to be. This is about us creating a machine, having complete control of a mathematical system such that we can create a machine that's going to work in discrete increments continuously in a particular cycle that we create, and it accomplishes certain work or purposes in doing that. I'm trying to help you to understand or point in the direction of the way a person has to think in order to be able to use this kind of math whenever they're designing an actual piece of equipment to accomplish a purpose that using these primitive equations. Anyway, I'm not going to let this go on any further. It's the reason why I waited till now to do this one, because it's a little sort of a delicate subject. But as we go further in the videos that are already up, and many of you have already watched some of them, hopefully this is going to start making sense for you, or put the pieces together. I'm just basically putting pieces together. I'm making all of the stuff that other people have been researching for the last umpteen years into a package that's saying, hey, look, this is the way it is. Thank you. And everybody's pretty much on the right track in a lot of ways. It's wonderful.